Good evening. My name is Wahid Lutfi. Welcome to my Web University free education videos. In today's session, I'm going to teach you how to write a Bash graphical user interface scripting with Zenity. The Zenity is the package that we are going to use, but in order to do that one, you have to know shell scripting, in particular Bash scripting. Did you ever wonder how you're going to write graphical menus in dialog boxes? So if you do, Zenity is your friend, and with Bash scripting, you can do that one. In particular, you can do this one for any programming language that you particularly love to program, let's say C++ or Python or Swift or Go language. Does not matter what programming language you use. You can still write a Bash script to just have the interface working with you as a graphical user interface, and then that interface is going to communicate to your programs, whether it's a binary C++ executable, or Python script, or a Bash shell script itself, a awk program, or running a command. So today's session, I'm going to show you how to do that one. Let me just get into this terminal session. As you can see, I am already concatenating the content of one of the program called exec.sh. .sh, I give the extension .shell because it's a Bash shell, as you can see on line 1. Basically, this script from line 1 through 35 will allow you to run any Linux command that you provide and then execute it for you, as if you're just going to run it in a Zenity terminal session with certain size and all these attributes that I set it up here. I'll explain later, but all you have to do is just know that that script is there for you. Let me just PWD here and say what are my latest two files .sh. So if I say tail -2, then you will see that these two files I have prepared for you as of today. And these are ready for you to just look at the content of it. And so before I just run them, and let me explain a little bit on the script itself. So Vim, opening it, I'm opening it in a VI improved edition. As you can see on line 1, I have the shebang user Benny and V bash, and then line 3 through 7 are commented. And the rest of the script is basically doing Bash scripting commands that we are using Zenity environment variables, and also passing some kind of options and variable settings. If the analysis statement, and very simple, but it does a big job to run and then any Linux commands in GUI mode. All right, so you just are giving that information here. So let me explain the lines one by one, what I'm doing here. So you can just even use this one as a template to write your own script for yourself, and then go use it in GUI mode. The option that line 1 through 35 is basically the full program. So you can just watch it and read it. If you want, make a comment, I'll put it on the description section, the whole program for you. So you can do it for yourself, as well as for school or homework, or when you have a job and you want to help yourself at the job, that would be great. So here, the line number 9 is the command that we're doing $, left parentheses, and at the in line 14, the right parentheses, and closing it. Within this left parentheses and right parentheses, basically is the subshell command that we're passing the Zenity command with a number of options. The Zenity -- entry will just open an entry and is giving a title. As you can see, this slash is meaning that go to the new line. So the one line horizontally is going to be too much to display it. So I put it in multi-lines, and that's how you break your long line of a script into multiple lines by putting a backslash here. You can do that in Python and C and C++. It is basically, I'm inside the Vim VI tutorial, and you can do that one. So all these other options, you can see it is plenty self-explanatory. It explains itself. And then here, in line 16, I say check if the command is valid. You don't need to just check for every command, that there are thousands of Linux commands. You don't need to just check for every command, whether printf command is there, or if statement, or pwd, or systemd. That would be too much. By doing just this line 17 and sending the information to dev null, this is the command that is read from the command line. As you can see on line 9, I'm reading the whole thing from the entry that the user gave me, the command, and then I store it into this variable command. So once you store it into the variable command, now you are going to run that command to see if it's a valid Linux command or not. If it is a valid Linux command, you don't want the output to display on the screen. If you want the output to display on the screen, you don't need this greater sign dev null. It will just display it on the screen. But I wanted to send it the dev null, so it will not display it at all. And then this 2 greater sign dev null is for the purpose of a standard output. If standard error. That 2 is a standard error. If you're sending anything that you want to just suppress the standard error, then you're going to do 2 greater sign dev null. And this one is kind of like the same syntax as a 1 greater sign, the standard output. And then 0 is a standard input. So this is when you're not putting any number, it is assuming that the greater sign is redirecting to dev null, whatever the output of this one, and that is normally displayed on this, the standard output, which is file descriptor 1. So in this case, I'm going to validate this command, and if the $ question mark equal to 0, then means that this command was a valid Linux command. See how simple it is there for 1 line of checking 1,000 lines of command dynamically, that you don't know what the command are going to be printed, a valid command or non-valid command. And then you just check it here. If that $ question mark equals 0, that means the function returned successfully, and then it executed the command. Otherwise, it's going to be just coming here, says that on the else part, it says the command was not valid. If it was valid, then we're going to set the output file, and whatever the path you specify here, I specify this path to be on my home directory, program shell directory, and then whatever the command.out file, that later on I could remove that out file here. So here you could just see that I'm going to put it into this out file, and then the out file is some place right here. I'm creating the out file, and then later on, when I'm done with the work, I'm going to clean after itself. You need to make sure that if you're just doing it for 1,000 commands and you're creating every time the command.out file, you want to make sure that you delete it yourself, rather than leaving the directory with all these output files that every time the user run. Because the command is sufficient enough to just create it on the fly dynamically, you can clean it dynamically as well. So it will be a cool script to run. And then here the title and all that information, as you can see, and then the checkbox, I can click and say, yes, I read that information, and so on. So let's just look at it again. I'm going to close it and then clear my screen, say cat -n exec.sh. So as you can see, this is the entire script. I'm going to now run it, say exec.sh. And as you can see, it's going to prompt me for a command that I need to type in. So this is the prompt that it is doing it. So if I want to run the pwd print working directory command on the Linux, it says Linux command to run. What is your Linux command? And I type in pwd, then I click OK. Now it's going to just open another command because that was a valid command. And it does say that, okay, that's a valid command successfully. Your command was pwd, and the output is written there successfully for you. Because I'm moving it around, sometimes this doesn't just automatically refresh right away. So you just have to be a little bit patient because of the speed of the bandwidth and of the network, as well as the graphical user interface, as well as the server itself, processor memory. So this one I could say click yes, I read it, and then I click OK, and I'm done with it. So now if I just run the same script again, this time I could just run another command. Let's say, for example, I'm going to run the command, say, go ahead, do this ls-l on the current directory and see whatever files I have. It says run the Linux command. I say, what is your Linux command? I typed in ls-l, and then I click OK. And then this one, it will just open another dialog box here, which I'm going to move it again here so you can see. And this one, since the output is a little bit longer, I have this scroll bar also that I enabled. So I can just click on yes, I read it, and then I am able to just move things around afterward. Once it refreshes, you can see that I can look at the scroll bar and just move up and down, and then look at the entire output. But because I'm on this current directory, what if I'm just doing the same thing, but I want to run it on a directory that I don't have permission? So if you don't have permission, and for example, let's say you're running the ls-l, and then uppercase R, meaning recursively on /etc directory. So etc directory, some of the files are permissive. That means that anybody could list it. Some of them are not. So when they are not there, it might not just run it, say this is list was not a valid command, when it is actually a valid command. So the script was just looking at see that this is there. But now if I run the same command, ls-l-r etc, notice this one is a valid command from this. But within Zenity, it was just seeing that as if I was not having that option. So this is a very, very long command, and that is there. I'm going to Control C out of it, but clearing the screen, ls-l r etc star.com file, just to list those ones, you can see that it is right away showing up there. But at the same time, I want to do this. Since the exec.sh ran without issue, because with issue because of the permission, I'm going to do sudo and then run the exec.sh here. So let's do this command, say sudo /exec.sh, and then we run that one. It's going to prompt me for the password. So it knows that I have a sudo access, and then since I do have it, it's going to just open up the prompt here. Oh, this is because I'm on an X Windows session. Unfortunately, this will not work unless you're on a actual desktop. At this time, it is Xming is saying that, this user sudo does not have the privilege. So the way you work out of this one, if I could, let me just try to do this one. Echo $display, and then I say sudo su dash, and then now I can still not open an X terminal, as you can see, because of that setting that is there, since I logged on with a different user. So I'm going to copy /home/wlutfi /.x authority to root .x authority file. So now I have root.x authority. That file is the same as the one for home wlotfi.x authority. Yeah, they are the same size and the same thing. So I'm hoping that I can now open. No, I cannot do it. So without this one, if I just do the display here is set, I'm going to do a sudo su dash. Now I'm gonna say echo $sign display. And that the good thing is that my display is not set. So when I did the export X authority, the display, as you can see for user Wahid, was localhost. So I'm going to say export display is equal localhost colon port, 10 display 10.0. Now I do xterm, see if, yeah. So this is now setting my xterm session because I copied the .x authority as well as set my display. Now I should be able to run any xterm session Zenity commands with root privilege. That means I can run my program from the X session. So here you can see I can say X clock and it will open X clock, or X eyes, it will open X eyes. Similarly, if I do Zenity, it will do Zenity. And here I could just close this one, clear my screen, and then run this one. ID is here. Now I can do .exec.sh. This time I need to be on the home directory, wlotfi programs, and then shells, and then clear my screen. And then so at this time I could just let me just make sure that export ps1 is equal. I'm gonna just say root at my web university or something. So here I'm just gonna say pound, and that's good enough. That way I have a smaller screen here. But you can see that here I'm on that directory, ls-ltr exec.sh is there. So I'm going to say, okay, ls exec.sh is there. I'm going to say exec.sh. When I run that one, it's going to prompt me for the actual dialog box this time, because it is having enough permissions to open it. The reason I'm just doing it this way is because, let me move it out. Right here, you can see when I move it out, and the terminal is a little bit kind of like getting updated, but it took a while. So now it is updated. You could just basically type in any command, ls-lr etc. Remember last time it was just failing because of the sudo privilege. So now I say recursively do that one, but it's gonna just run for a long time. And I'll leave it just to show you that when you have privilege, it's not an issue there. And right here, it does show the list there. So if I just go here and then say that when this one freshes, you can see the cursor is here. Now I can move up. So every files that is on the etc directory recursively with the -lr, it runs that command. And the nice thing is that on the top, I'm showing you what command you passed in as argument. Execute Linux ls-lr on etc command. So you could see that one. And on the top, also, I'm showing here, this was your command. Your command was this, and then it executed. So you can move up and down to read the entire thing. And when you're done, you just say okay, and it will close it. Similarly, if I just want to run another command, let's just run another command. This time we're going to run the df-h for disk format or disk usage of the system. So let me move this here, right here. I'm going to type in df for disk format or disk usage. The -h meaning human readable. that's good enough for that output. And then now I passed in that argument is going to run the df-h on this command here. And as you can see here, df-h is there, and then the output is right here. Okay, so you can also say, yes, I read it, and then click OK, and that will close. Now I'm going to run another command. This time I'm going to run, let's say, get the stat on the actual binary executable. So you can see here, this is the file, and I'm going to type in stat, the stat command, to get the statistics on the exec.sh itself, the shell script itself. So you can see that is there. And this is the output, which I'm going to bring it up here. And then when it refresh this window, you can see it looks nice for the command. Your command was this, and then this is the output. So you can see the read, write, execute. As you can see here, the actual script, and then the same thing here, you see the read, write, execute, which is 700. 7 is this, and the rest of them this. And then dash, because it's a regular file. So you can see all the detail here. The access modification, today it was updated, the 21st, and all that, and details. The IO block, input output block, and then the name of the file, everything is there. So what if we want to do one more command or not? Let's see, just we are gonna say this time, just show me content of a file, or just maybe this file itself. We can just look at the file itself. So the command would be like cat command, but I'm going to say cat -n, and then let's look at the exec.sh itself here. We run that one, and the output is gonna be shown here. But this is dynamic. Whatever command you do, it will show you that this is the command that you passed on, cat -n exec. And right here it says cat -n exec command. And then this is the output of the actual command. So imagine how, generalized, or this is like a template. You write one program to do as many thousands of commands as possible with one simple, and this 25 lines or 27 lines. Some of them are commented, right? So then you could also, you don't have to just go on the current directory. If you specify the path to a file that exists, you can just run it in there. So let's say we run it, say cat -n, and look at the contents of etc os-release file. etc os-release file. And then the output of this one is also showing you that you're running Linux Ubuntu and the long-term support version 22. And you can see here when you're looking at it, basically this is your command was. Let me just move it below here, and that's, you can see that your command was cat -n etc os release, and then on the title it says the same thing, and then the output is 12 lines of what is the content of etc os released in Linux. It shows that I'm running Ubuntu version 22 long-term support. And then you can just move up here and then say, yes, I read this information. When you click on yes, I read it, you can do it. Even if you want to just cancel it, you have an option. You just don't have to provide the commands that you want to do this. But at this time, let's just run a command that doesn't exist. So for example, if I just say the command by accident, and instead of cal command or ncal, I just say calendar. Let's say I say calendar. So I type in calendar, which is not a valid Linux command, but cal is. And so if you create an alias calendar that point to cal, yeah, you can do that one. But since that command was not there, your command was for calendar, actually, it did give me the information for calendar also. So it did recognize it. But let's make a typo and just say, I'm going to just say something that it does not exist here. Sometimes it's hard to just, when you know so much of these Linux commands, to just type in anything, even a short command like dd or something, it's a command. And like nm is a command. So I'm going to type in some garbage here like this. That is not for sure a command. So let's just run that, and it says the command was not found on Linux. So this is good. The script is working. If I just gave any garbage that is not there, and then that command will not execute. But let's just run the command calendar, and notice that this one, if I want to get the Linux epoch calendar, I could say calendar 19070. Calendar 1, calendar 1 for January, 9070 for the epoch calendar will be displayed there for January 1st. I mean, January 1st was the epoch calendar started. And right here is the output. So I'm going to just do one more thing before I just close this one and show you this, that, and then close it here. And this one, you can say echo $? Is just telling you that it's there. So just for your knowledge, I'm going to do cat -n exec.sh. This is the entire 35 lines, and you are welcome to just use this one for your own scripts, and just modify it any way you want to do it. Make sure that when you're releasing it for other people, so you don't charge anything. It is free because I have the copyright here. So you're welcome to just give it to other people's for like kind of open source kind of information, and so they can just help themselves. Okay, so and this is the first program. I'm going to just now change my terminal. I'm going to exit out of this one completely, and I'm going to come back here on this other one. Notice on this other one, I'm not running any command that is with root privilege. So I'm going to demo another program called cat manual.sh. And then clearing the screen, ls-ltr start.sh, tail -2. I told you that I have two of them. I already showed you the exact. Now I'm going to do the manual and there. So clearing the screen and putting a semicolon here, cat -n manual.sh will just display this file on a nice interface here for you. Line 1 through 32 is the entire program. Again, the line number 4 and this one is saying to display Linux manual pages and graphical user interface. So this time, instead of running a command, we're just helping the user to give the Unix manual pages for a command that the user wants. How cool is that, when all that you have to do is that provide a command like man pwd, and instead of just showing in a text command, we just use that manual page to clear the screen. So normally you say man pwd and you get the output here, right? So in this case, we're going to say manual pwd here, and then manual.sh. So a man pwd was showing that, and then this time I'm going to say manual.sh, which is my program that is going to do the same thing with pwd. So now it's saying that you need to put a / here, because it is not on the bin directory, so it does not find that script. But if you put a / meaning that from the current directory, run that program, and it will just open up here, and it just says, okay, pwd was the command that you want manual pages, and then a title, and then here's the man PWD section 1 is displayed, and then you say, okay, I got it, thank you so much for showing me, and you get out here. So imagine if you're on the command here and you say manual.sh. So if I just did not know what this script does, it's going to just say a usage for the script. It says /manual.sh. It says that you have to give one of the Linux command that you want to get manual pages, and then I'll produce you the output for that man pages. For example, systemctl, pkill, pwdx, printf, df, pwd, ls, any command that you pass on, it will do it. So let's say, for example, manual and .sh, and then we say pkill command. That process kill is the command in there. So it will just create this one and right here, and as you can see, is the process pgrep and pkill. All of them are together in one command. This pgrep, process grep, or pkill and process kill is there. And then I say, okay, I read that one. Let me just this time I'm going to clear the screen so you can see when you are doing it. I'm going to clear the screen here and say /manual.sh. It's going to say, give me a argument. So clear the screen, manual.sh, and then say systemd. If I want to get all the information about systemd, which is Linux Red Hat 7 and up, and also Ubuntu 16 and up. And then Red Hat 8, CentOS 8, Rocky 8, all of those ones are using systemd. And this is the output for systemd. As you can see, you can click on this one. Yes, I read it. You go with the scroll bar and just read the entire thing and familiarize yourself with the commands, and then understand the options and everything, and then say okay, and then you're done. So here again, manual.sh. This time I'm going to do a printf command. This is a section 3 of C and C++, especially C programming language, or section 1 is that actually section 1 is the print command with Unix printf command. So now printf is also for section 1. But if I do this one and say man minus S3 printf command, man minus S3 printf command, then this will just give me a section 3 of this. As you can see here, section 3. So you can read the entire thing and just running the same command with our options. Let's say I'm gonna just do the same thing, say manual.sh here first, and then it's gonna give me that information. So this was the output. I'm going to do ./manual.sh minus S and then 3 and then printf statement, because I want to see if I can give pass those options, because there's an option of -S3. It did not understand that option, so it is not gonna work on this one. I have to read the arguments and parse it differently. But for now, I can just do man minus S3 printf statement and read it, and then see that, yeah, that is there. So clearing the screen here. If I want to modify that one and just for the section of it, I could just do that as an option, vim manual.sh. Let's see if I could just incorporate that section to the screen, and then manual.sh, and then systemd or pwd or something. It would work on this one. Yeah, you can see it is working on this one, and then so there's no error or nothing, and I could still rewrite the script, but I'm not satisfied with this solution. But just for a learning purpose, it's good that you see what I did here. Some part of it is not sufficient enough because I'm doing it quickly. So if I do here ls command, it will just give me the output for the ls command. And then at the same time, it will just create the file and then clean it after itself after. And you can see that it is just a little bit more information. So now you can just move this one up and down. But if I do this one with minus S3 and then scanf, for example, that's also section 3 on the scanf for reading a variable. And now notice that it works perfectly good. So I'm actually happy with it because there's a quick fix. We just did it. It's not a problem. It is working for one command as well as other commands because I passed it within the dollar sign. So you can do a printf statement here. You can get the information for section 3 of printf statement, as well as if you just don't do section 3, you just do section 1 and it will give you section 1 command. And then whether you just do the default one, the printf statement, or just choose this minus section and just do 1 here, it will do the Linux printf statement here. Because the @array is just smart enough to know that the command is there. So I'll post this one because we fixed it and it is accurate. All of the information, and when I said I'm not satisfied, I was thinking that it's not gonna work for, let's say, like section 8 for a mount command. That is section 8, I believe, and then you can see it opens it there in section 8 there. Yeah, I remember the mount command in section 8, and you can just see it is opening it in section 8. If you just say, okay, don't give the section in front of it, can the script work? Yes, it does, because all I have to do is just delete these 2 lines and say mount command. It's gonna just know that is on section 8. The manual pages itself is gonna read the var spool share man pages directory, that tar.ganze file, and then user var share manual pages, and that has a tar.ganze file. The extension .8 will just know that this is a section 8. Okay. So I hope you like this one and you're learning from it. So here is what I did for the script, vim manual.sh. I'm gonna delete these extra lines and that I did not need. That was just for testing purpose. The thing that it did it to get it working is this command argument is passed on from one section, but then you want to get the @array, whatever is the number of argument that passed on, you run it the same command, and that would fix it. You don't need to just parse it and tokenize it and say arg v sub 1 is this, arg v sub 2 is this. $@ and $pound. $pound has the number of arguments as well as the number of arguments variables, but then $@ is the actual string that you're using it. Okay. Thanks for watching, and then I'm going to one more time run a manual.sh, and it tells you that you need the command to be provided. So I say manual.sh, and then let's say run the who command, and the manual pages on who does who's logged on the system, and who -r gives you the run level also. And that is the output there, and it is going to get refresh, and then you can see that it is there. You can move the cursor up and down, and you're welcome to enjoy it. Take care. God bless you all. So cat manual.sh is the name of the script without any line numbers. Clear screen, cat -n manual and .sh. I'm sorry, clear screen cat -n manual.sh. This line number 21, this was the most important one, that $@ and that has the number of arguments that are passed. That was the modification. So with this modification, I was able to actually get more than a number of arguments passed on and get it fixed. Thanks for watching. Please subscribe if you like to see more of videos like this. I know they're really long, but once you learn them, and they're going to be very productive for you on the systems that you use. Take care. Have a good night. Bye.